Welcome. In this video, we're going to use this graph given here to find the derivative of the function k evaluated at 0, given that k is defined as g divided by f of cosine of x, and the differentiable functions here, g and f, are pictured. Well, differentiable at most spots. Clearly not here or here or here. All right, so the first thing we want to do is find k prime of x using all the derivative rules we know. So k prime of x, we're going to use the quotient rule. So the derivative of the numerator is g of x times the denominator f of cosine x minus, and pardon me while I just scooch this over here, maybe a little higher up where it's out of the way. So minus g of x, so our numerator, times the derivative of the denominator. And for the denominator's derivative, we're going to have to use the chain rule since it is a composition of functions. The chain rule tells us to evaluate the derivative of the outer function, leave the inner function the same, then multiply by the derivative of the inner function, which I haven't evaluated yet, but I just wrote it down right there as cosine of x prime. Now, of course, back to the quotient rule, we want to divide this whole thing by the square of our denominator. So k prime of x is equal to g prime of x times f evaluated at cosine of x minus g of x times f prime of cosine x times the derivative of cosine is negative sine x divided by f of cosine x quantity squared. So negative times a negative is going to be a positive. I'm going to rewrite this one more time the easy way. That is, I'm going to copy and paste it. Those of you working on paper, you can rewrite it one more time, and the only difference is I'm going to change this to a positive and just leave this as multiplied to a sine x. There we are. So now, number 2, let's evaluate. So we're going to evaluate k of x, that is k prime of x, excuse me, when x is equal to 1. So k prime, now why did I say 1? Excuse me. K prime of 0. This should say when x is equal to 0. I have 1 on the mind. I apologize if I've been saying 1 this entire video. What I meant is 0. So k prime of 0 is equal to g prime of 0 times f of cosine of 0 times, not times, excuse me, plus g of 0 times f prime of cosine of 0 times sine of 0, this entire quantity divided by f of cosine of 0 quantity squared. Okay, so the derivative of g here at 0. So let's look. When x equals 0, we're along the y-axis here. And the slope of this line, get a straight edge, please, and draw a tangent line here. Okay, so as you can see, I went ahead and drew the line tangent to g when x equals 0, and the slope of this line goes down to over 1, down to over 1, so the slope of this line is negative 2. All right, so I have negative 2 times f of cosine of 0. Well, cosine of 0 is just 1, so I want an f of 1 here. Plus g evaluated at 0. Well, g of 0 here is just equal to 3. Times the derivative of f evaluated at cosine of 0, which is 1. Times sine evaluated at 0, which is 0. Divided by f of 1 quantity squared. So again, we don't have to find the derivative of f when x is equal to 1 because we're multiplying by 0. And I said again, for those of you following along, this is the second of 2 videos, and this occurred in the previous video. Now, pardon me while I make a little space. I'm going to hide this material and continue with just this on the screen. On your own paper, you should just continue writing this down and not erase or move this. All right, here we are. Let's continue now that we have a little more space. We're finding the first derivative of k evaluated at 0. So k prime of 0 is equal to negative 2 times f evaluated at 1, when x is equal to 1 here. Our function f here in blue has an output of 5. So I'm going to multiply this 2 by 5, and then I'm going to add 0 to it. So this goes away, vanishes. And I'm going to divide everything by f evaluated by 1 squared. And so that's 5 squared. And of course, this becomes negative 2 over 5. Hopefully you are feeling more confident in your abilities to do calculus.